Hello good people, I'm going to talk about the mole. The mole is a tricky but very important concept in chemistry. Without it, chemical calculations would be nearly impossible. Although we are not going to do any chemical calculations just yet, it is important to get a sense of this concept. In chemistry, the mole, often abbreviated MOL, is used to express or measure the amount of any substance. It represents a certain quantity. What do I mean by that? Well, let's look at a few examples that you might be familiar with. If I say I have a pair of goats, well, it means I have 2 goats. If I'm talking about a trio, it represents 3. If I'm talking about a quartet, it represents a quantity of 4. If I say a dozen of goats or a dozen of eggs, I'm talking about 12. If I talk about a century, I'm talking about 100 of something. A gross represents 144, and a grand represents 1,000. In a similar fashion, a mole represents a number. The main difference is that the mole represents a rather large and cumbersome number. So if I was to say that I have a mole of rubber bands, it would mean that I have 6.02214,076 times 10 to the 23rd rubber bands. This number is often rounded down to 6.022 times 10 to the 23rd. It is still a ridiculously large number. To give you a sense of scale, there are approximately 1 times 10 to the 11 and 4 times 10 to the 11 stars in our galaxy. The mole represents a quantity much larger than that. This quantity is also known as the Avogadro's number or Avogadro's constant. And it has a symbol of capital N and then a capital A in the subscript. Why do we bother with the mole? Well, it is very hard to measure out a single atom or a single molecule. However, a mole of them, well, that is a different story. Let me use fluorine as an example. Recall that the number in orange, 18.998, gives the average atomic mass of fluorine in AMUs, atomic mass units. And so I can say that a single atom of fluorine has a mass of 18.998 AMUs. That is all fine, but it is very hard to measure this out on a balance. However, 1 mole of fluorine atoms, or 6.022 times 10 to the 23 fluorine atoms, equals 18.998 grams. Now that is a mass that I can actually measure out. Please note the change in units. If I'm talking about a single atom, the mass is given in AMUs, atomic mass units. Whereas if I'm talking about moles of atoms, the mass is given in grams. By the way, this is not something that only works for fluorine. This works for all of the elements in the periodic table. So let's do one more example. Now we have sulfur. A single atom of sulfur has a mass of 32.066 AMU, whereas a mole of sulfur atoms has a mass of 32.066 grams. We will come back to the concept of the mole later on. For now, the main idea is to accept the mole as representing a quantity. In much the same way that when I say dozen, your mind immediately thinks of 12, so when I say mole, you should start thinking about 6.022 times 10 to the 23rd. That is all for now, and I will see you on the flip side.